let a and b be integers, and let m be a positive integer. So we'll say that a is congruent to b modulo m, and we write it like this. So a congruent to b modulo m if m divides the difference a minus b. So if m divides a minus b, then we say that this holds, right? So let's look at this more carefully. So for example, 17 is going to be congruent to 5 mod 6. Why? So why is this the case? Since 6 divides 17 minus 5. So 17 minus 5 is 12, right? So 6 divides 12. So this is equal to 12. So 17 minus 5, this part is equal to 12. So 6 divides 12. And so 17 is congruent to 5 mod 6. Another example, 20 is congruent to 4 mod 8. Why? Since 8 divides the difference, 20 minus 4. So 20 minus 4 is equal to 16. Since 8 divides 16, then it is congruent. And as an example of not congruence, so 29 is not congruent to 5 mod 7. Why? Since 7 does not divide 29 minus 5, which is equal to 24. Okay, so I mean it's a definition, but what does this mean? So let's look at this a bit differently. So what's happening here, let's focus on this mod 6 example here. Like, what does it mean that 17 is congruent to 5 mod 6? So what this means is that if you think of the integers divided by 6 and you look at their remainders, what we're saying here is that 17 and 5 have the same remainder when they are divided by 6. So let's look at that. So if we do 17 and we want to divide it by 6, so 17 is going to be 6 times 2, which is 12, plus 5, right? And also 5 is going to be 6 times 0 plus 5. So you see, both 17 and 5 have the same remainder when you divide by 6. Another example is if you do, for example, 11 will be 6 times 1 plus 5. And so this means that 17 is congruent to 11 mod 6. And we can check that, because if we do 17 minus 11, we get 6, and of course 6 divides 6, so this is true. You can do that with any of those numbers. Now, this is the same here. If you divide 20 by 8, so it's going to be 16 plus 4. So you'll see that the remainder of 20 by 8 will be 4. And the remainder of 29 by 7, so will be 1, which is different than 5, right? So in other words, what's happening here is that we're sort of looking at equality. So this congruence is supposed to be like a form of equality. It's not exactly equal, but it's like equality in terms of the remainders. So we're not saying that A is equal to B, but we're saying that A divided by M, the remainder of that, and the remainder of B divided by M are equal. So that's what's happening here. And to show a little bit more of that, this is actually going to sort of behave like an equality. And so let's show that. So let's show some properties. So first, if A is congruent to 0 mod n, so A is congruent to 0 mod n if and only if n divides A. Well, by definition, A is congruent to 0 mod n. So what does this mean? So this just means that n divides A minus 0, which means that n divides A. So the definition of this just means that n divides A, and so this is the same. So A is congruent to 0 if and only if n divides A. And again, this makes sense because we were talking that congruences, we're talking about what is the remainder by the division. So if the remainder of the division is 0, that means that this number has to divide this number. The only way for the remainder of A when divided by n to be 0 is if n divides A. The second property, A congruent to A mod n, so this will always be true. Now why? So again, what does A congruent to A mod n mean? So this just means that n divides A minus A, but A minus A is 0, and so of course every number divides 0, so since every number divides 0, it's always going to be the case that A is congruent to A mod n. And again, if you interpret this in the way of the remainder of A when you divide by n is the same as the remainder of A when you divide by n. Let's look at the third property. So the third property says that if that A is congruent to B mod n if and only if you have the other way around. And again, with the remainder language, that this should be obvious. So if the remainder of A is the same as the remainder of B when dividing by n, then of course the remainder of B is the same as the remainder of A. But we can look at that from the definition. So if A is congruent to B mod n, so what this means is that A minus B, so this means that n divides A minus B, which means that there exists some k such that A minus B is equal to nk. But now if you multiply by minus 1, this just means that B minus A is equal to n times minus k. So n times minus k. But now again, if B minus A is n times an integer, that means that n divides this. So thus n divides B minus A, which implies that B is congruent to A mod n. And actually all of these implications are two ways. You can actually go in both directions here, essentially. So yeah, and so this is just showing that these are just properties showing that this acts like an equal sign, right? Like that everything is equal to itself somehow, and that if A is equal to B, then B is equal to A, right? But again, it's not actual equality, it's this equality in terms of remainders. Now the last one is called transitivity. So it's like if A is congruent to B mod n and B is congruent to C, so if A is congruent to B and B is congruent to C, then A is congruent to C. That's what we're saying here. And so to see that again, so if you have A congruent to B and B congruent to C, let's say both of them mod N, what this means is that you're going to have K and L such that A minus B is equal to NK and B minus C is equal to NL. But so what this means is if you do A minus C, so if you just take these two equations and you add them, notice that the minus B cancels with the B and you get the A minus C. So then the A minus C is going to be equal to NK plus L. So take these two equations, add them together, factor out the N on the right, and you get A minus C is equal to N times K plus L. But then this is an integer, which means that N divides A minus C. So thus N divides A minus C, and this implies that A is congruent to C mod N. So once again, congruences behave a lot like equality in some ways, right? Every number is congruent to itself. We can reverse congruences, and we can sort of chain them together. But again, congruence, it's not saying that the numbers are equal. It's saying that they are equal from the point of view of remainders modulo n.